Hi everyone, welcome back to JDCodebase. This is the video number 37 of our LeetCode 75 study plan series. And today problem is the longest zigzag path in a tree, binary tree, LeetCode number 1372. And honestly, when I first saw this problem, I did not even understand what zigzag means in a tree. So I'm not going to start with a tree. I'm going to start with something you already know from real life. Once that clicks, the code will write itself. So let's get into it and read the problem statement. You are given a root of a binary tree. A zigzag path for a binary tree is defined as below, as follow. Choose any node in a binary tree and a direction, left or right. If the current direction is right, move to the right child of the current node. Otherwise, move to the left child. And change the direction from the right to left or from left to right, and repeat the second and third step until you cannot move in the tree. So zigzag length is defined as the number of nodes listed at 1. So return the longest zigzag path contained in the that tree. So let me simplify this. We have a binary tree, like this. This is a binary tree, and we need to find the longest zigzag path in it. So now what is zigzag path? And it means you keep switching direction as you move down, like left, then right, then left, then right, or you start from right, then left, then right, then means left, right, something like that. The moment you go same direction twice in a row, the left or right, the zigzag breaks, right? Like this is right, left, right. Now there is no more left side, so the zigzag path is the 3 length. So we want the longest such path, and we measure it in number of edges, like node to nodes. Like there are 4 nodes, 1, 1, 1, 1. But the connection, these red lines are the 3. So we have to count these edges, node to nodes. So forget about the tree for a second, for a moment. Forget about the tree. I am not going to tree, not using the tree. First, understand the zigzag path. Look at this simple path going straight down. So wait a second. Yes. So as it, I went to left, then right, then left. So that is the 3 edges. I draw the 3 lines. 1, 2, 3. So that is a zigzag of length 3. Now look at this path. This one, 1. I went left, then left again, and same direction twice. So zigzag is broken here, and length is reset every time. So that is the entire one. Switch the direction, and zigzag grows. If the same direction, then zigzag reset to 1. Now there is how to think about this. When you are standing at any node, you are visiting a node, and someone called you from above. They told you 2 things. Which direction did you just come from, left or right? And how long is the current zigzag so far? Now you decide what to pass to your children. If I came from the left side, then zigzag wants me to go right side. So I tell my right child that length +1, you are continue the zigzag. If for the left child, I tell my left child that length is the 1 and you are starting as the fresh. And if I came from the left right side, the zigzag wants me to go to the left next. So I tell my left child length +1. So at every node below, we go deeper. We also check is the current zigzag length the biggest we have seen so far. So we keep one variable called the max. We update it every node at the end. So that is, let me write the code so you understand it. So first, this is our main function. It's take the root of the tree, initialize a variable called the let max is equal to 0. Here this max is our answer. We will keep updating this as we go the tree, and let's define a function dfs. So this function takes the 3 things. One is the node, direction, and length. So this is our working function. It takes 3 things: the node, the current node, and which direction we came from, the left or right. if I came from the left, then it's help me to go to the right side. And how long the current zigzag is the maximum length. So first write the base case, because this one is a recursion. We have to write the base case first. If we walk into an empty space, then just stop this. Means there is no left, there is no right. So just stop this and update the maximum length every time. First math dot max and with the maximum value and with this length. So means this is our answer. This maximum value is our answer. We have to update it. Maybe this is the longest zigzag we have seen. And now I reach at that point, like I reach at this point 1. Now like this. So at this point I have to how I this means analyze, like I have to go to left side or right side. For that, if direction is the left side, just take this triple equals for safe case and call this recursion node dot right. Now this time give the direction right and give it to length plus 1, means it's continue this length. Else for the we also have to check to the left side also, means the opposite side also, but this time we have to take the left and 1. Now if direction is the I'm coming from the right side, then we have to write here node dot left side must be moved and this take the left as the direction and it's carry the length plus 1 and DFS node dot right direction and 1. So this one is the main logic. This if else condition, this 4 line of code, this 6 line of code is the main power of this mind of this heart of this code. If we came from the left, go right side to continue zigzag and with the length plus 1 value, and else for left side just reset the length by 1. Now if I am coming from the right side, then use this DFS for this, means we pass the length plus 1 every time for the opposite direction, and for this same direction just reset it, because this new edge itself count as the length 1. Now how to start this recursion? For that, just call this DFS root dot left and I'm coming from the left side, then and give it to 1 as it is the root first element. Root dot right, its point not the comma, and give it to right and also give it to 1. And in last we have to return the maximum value. Return maximum value. So we kick off from the root, we try both the direction left and right, we pass the length 1 because moving from root to its child is already 1 edge, and at the end we return the max. So let me run this code. The code is very simple, but statement is a confusing, but the code is very simple, nothing special in this. It's simple if else code. The whole thing in the 4 lines. Walk down the tree from the top to bottom. At each node, check which direction came from, and continue zigzag in the opposite direction. Like if I coming from the left, then for the right direction, take the previous length. If I'm coming from the left and I want to move to the left side, then reset the length by 1. And it same apply for the right side. If I coming from the right side and for the left direction, just take this length, previous length, and move on. And for the same direction, always reset. For opposite direction, pass this previous length by 1. And track the longest length seen so far by this math.max, maximum and length. So start at the root, go left, return the means length one and direction list. This is all about that. And here time complexity here is the big of n because we visit every node exactly once. So big of n is a time complexity, and space complexity also big of n because the call stack goes as deep as the height of the tree. So worst case, that is the n for a skew tree, and that is for this longest zigzag path, day 36 or day 37. And the key idea is simple. At every node you know two things: where you came from and how long the zigzag is. You pass that information down, you grow the zigzag in the opposite direction, you reset it in the same direction. Just that's it. No map required, no backtracking, just pass information downward and keep track of the maximum value. And if this video helped you, give it a thumbs up, subscribe to JDCodebase if you have not already. Drop your question in the comment. I read every single comment. So see you in the next video.